Hello guys, welcome to another video. Um, Today we're going to do Unit 3, October 2024, Question 3. So let's start right away. A student determined the refractive index of a liquid using the apparatus shown. Um, the student filled the tall beaker with water. He used a meter rule to measure the depth H1 of the water. Describe an accurate method to determine a single value of H1. Okay, so a liquid's refractive index is being measured. There is water in a tall beaker. Um, there is a stand, there is a pin, there is a cork, a steel nail, and the image of a steel nail. So the student filled the tall beaker with water, and we have to say what's an accurate method, not just a method, an accurate method to determine a single value of H1. H1 is the height, this height. We have to measure this height. And we have to say an accurate method to determine a single value, which means we cannot mention take repeats because it's just for a single value. Um, so of course, the best way to measure this height would be to use a meter rule. So you place a meter rule here and measure the height. But there are certain precautions to how to use the meter rule. Like even though it's a very simple apparatus, there could still be some errors while using it. Now this type of question where they ask you to determine accurately the value of a height is repeated in almost every single Unit 3 paper. So the situation is different, but there's always a meter rule being used to measure some height, some distance, and you have to say how you do it accurately. So the precautions are more or less always the same. So the first thing is, whenever you're measuring, like over here, since you're holding the meter rule vertical, you place it somewhere here, close to the beaker, and you make sure the ruler is vertical. Because even if it's slightly tilted, you might read wrong value. So the first thing is, so use a meter rule to measure the height. Place the meter rule close to the beaker. This is important because even if there is like some distance, like you place the meter rule over here, um, because of the distance between them, you might get a wrong value. So place it close to the beaker. And make sure it's vertical. How do you make sure the ruler is vertical? You can use a set square for that. What is a set square? It's that triangular geometry thing. The triangular thing in your geometry box. That's a set square. So if you place a set square here and it perfectly aligns with the horizontal surface, then the ruler is vertical. Um, what else? So the reading that you take from the ruler. Uh, so this is, let me draw the ruler like properly because, so this is over here, like this reading is what you're measuring. Now, whenever you're measuring such a reading, it's very important that you look at it perpendicularly. So you look at it from here. If you look at it somewhere from above or somewhere from below, you will get a wrong value because of an adder called the parallax adder. So look at the reading perpendicularly to avoid the parallax adder. So there you go. Those are all the points you should mention. Moving on to part B, the student placed a steel nail at the bottom of the beaker. He viewed the search pin and the image of the steel nail from above while adjusting the height of the search pin. When the search pin appeared to be in line with the image of the steel nail from all angles, he measured the value of H2. The student varied H1 by adding more water and repeated the process. He recorded the following data, criticized the recording of the data. So sometimes they tell you a lot of information that's kind of like background. Now, most of the times it is important, all the information that they tell you. But sometimes it might be for a part that comes later in the question. So when you're about to read this part, also look at like what the question is actually. And if the question does not relate to that, so like if it's just a simple question, like over here, there is some data given and you have to criticize the recording of the data. This is again a common question. It appears in every single Unit 3 paper. So there are certain values given for H1 and H2, and we have to criticize the recording. Like we have to say what's the fault with these readings. It's 3 marks, so we have to point out 3 faults in this. So let's look at the data. So 20.7, 40, 49.6, 58. 15, 28.5, 37.3, 451, 451. That is definitely an anomaly. It's too large compared to the rest of the data. So it should be in 40s or 50s, not 400s. That's one of the problems. What's the other problem with the data? Um, the first reading is 20.7. That's 3 decimal places. The second reading is 40. That's just 2 decimal places. 49.6, 3 decimal places. 58, 2 decimal places. What does that tell you? The student was being careless. Um, he did not like, so if for 20.7, he looked at the third point, the third decimal, and he ensured that it was 20.7. But then when he took the second reading, if it was exactly 40, the student should have ensured if it was exactly 40 or not. And that should have been 40.0, 49.6, 58.0, 15.0. Like that. There should be consistent decimal places. Now, there are 2 points here. There are decimal places and significant figures. They are 2 different things. Oftentimes, students think that decimal places and significant figures are the same thing. No, they are not. They are different. So we are talking about decimal places right now. And I put zeros here, point zeros, and you might be like, but that doesn't make a difference. It does actually, because when I look at 40 centimeters, I do not know if it is exactly 40 or not. Because if 20.7 was recorded to that precision where it is 20.7, then 40 should have also been recorded to like 40.0 or 40.1 or 40.2. Precision should have been the same. So the second problem is the decimal places. They're not being used in the same way. They are inconsistent. Uh, what other problem could be there with the data? So there are just 4 readings. Normally, when you do an experiment, you take at least 5 readings or even more. 5 is still less. Like if you want to plot a graph, you would need more data. Even without plotting a graph, 4 readings are less to judge the trend, to like accurately measure something. Uh, the student also did not take repeats. Like for 20.7, he and all other readings, he just measured once and decided it was this value, while there could have been a random error, there could have been a mistake. So maybe if he repeated 20.7 sometimes, it could have been 20.7 the first, the second time it could have been 20.6, the third time it could have been something else. And then taking a mean would ensure there is no um, adder, there's no systematic adder in there. It would improve the accuracy. So the 451 centimeters is an anomaly, which means it's a wrong reading. It should be discarded. But it's still recorded. So secondly, the student is using inconsistent decimal places, inconsistent number of decimal places for both H1 and H2. And since we just need 3 points, the student did not repeat readings. H1 or H2. And so like we did not take repeat readings and so did not take the mean. Like it's enough up till here, but just to elaborate. So there we go. Moving on to part C, the student used values of H1 and H2 to calculate values for the refractive index N of the liquid. His values of N are given in the table below. Determine the mean value of N. That's simple. Mean means just the average. So that would mean sum of all values, whatever values you're given, add them all up, making sure there's no anomaly. Like if, let's say, there was suddenly like, let's say there was in place of this, there was a reading 5.01, then that's definitely an anomaly because it's not following the 1 point something trend. So if there is an anomaly, discard that. Otherwise, take all values. Uh, so sum of all values divided by the number of values. There are 4 values, so 4. Let's calculate that. 5.41. That is the mean. Remember to use the correct number of significant figures. All of these have 3 significant figures, so I write the final answer to 3 significant figures. Sorry, I did not divide it by 4. This is 1.35. So yeah, like I got 1.3525 on my calculator, but I'm writing it to 3 significant figures because all of these are 3. If one of them was, let's say, 2 significant figures, then I would write this answer to 2 because your answer should have the least number of significant figures as in your data. Okay, like if in your data there's one value with three significant figures, one with two, then your final answer should be written to two, not three. Um, Determine the percentage uncertainty in the mean value of n. So when you're given a series of values, like over here we have four values of n, and you're asked to calculate the percentage uncertainty, in that case, the formula is to take half of the range, divide that by the mean, and times by 100. What does half range mean? So you find the range and divide it by 2. Range is just maximum value minus minimum value. So in the values that were given, the maximum is 1.41 and the minimum is 1.29. So 1.41 minus 1.29, that is 0.12. You divide that by 2 to get the half range. That's 0.06. You divide that by the mean, which is 1.35, and times it by 100. So you get 4.44%. So that's the percentage uncertainty. There are like three ways of calculating the percentage uncertainty, depending on what uh, data you're given. Whenever you're given a range of values, like a number of values, find the range, which is just max minus minimum value. Take half of that, divide that by the mean, and times by 100. So we're done with question 3 here. We'll continue with question 4 in the next video. Stay tuned. Take care. See you.